Hey guys, welcome back. It's Mr. Jet here. Today we're going to start lesson number 7. We're going to talk about inscribed angles. We're kind of moving on from when we talked about arcs. So I want you guys to first pause the video and think about these different definitions. I want you to come up with in your own words, a definition for each of these terms. All right, here's the definition for each of them. Make sure you notice your radius, diameter, chord are all segments. They stop. They have endpoints. Secant and tangent is a line, so they go through, they continue forever. Point of tangency was one that I noticed a lot of people messed up on, so make sure we pay attention to that. That's simply where the tangent touches the circle. And then we have minor arc and major arc. Minor arc being less than 180, major arc being greater than 180. Okay, so like I said, today we are going to start looking at inscribed angles and then this thing called an intercepted arc. Okay, so first of all, an inscribed angle, when you think about inscribed, we're talking about being inside of something. So it's an angle inside of a circle. So the way we define this is it's an angle that has its vertex on the circle. So remember a vertex, we talk about a vertex. If we have this angle here, the vertex is this point here. Okay, so it has this vertex on the circle and the sides of the angle that contain chords of the circle. Okay, so if we go down here and look at our picture here, this blue angle here is our inscribed angle. Because if we look here, the vertex of this angle is on the circle. And then we have these rays, these sides, that are creating chords of our circle. Okay, so we could have really any different, if I go over here, I draw a circle, and I put this angle right here. Okay, that is also an inscribed angle. It's inside, it's got its vertex on the circle. Okay, so this angle right here that we're talking about, that's an inscribed angle. Now, with inscribed angles, we also have these intercepted arcs that are created. Okay, so an intercepted arc has endpoints on the sides of an inscribed circle and lies in the interior of the inscribed angle. Okay, so all that's saying is when we have this inscribed angle, this blue angle that's created right here, this arc from here to here, we call that an intercepted arc. Okay, it's the arc that is intercepted, it's crossed by this inscribed angle. Okay, and so this arc from here to here, from this side of the angle to this side of the angle, we call that an intercepted arc. Okay, so we have an inscribed angle, it creates this intercepted arc. Now we have this property for this inscribed angle. So it says the measure of an inscribed angle is always half the measure of its intercepted arc. Okay, and so what we're saying here is if I have this circle right here, and we have this inscribed angle right here. Okay, so we have this angle that's created right here. This right here is that we just talked about, the intercepted arc. And so what this is saying is this inscribed angle that is right here, this angle ADB is equal to half of the intercepted arc. So it tells us the arc, which would be arc AB, they're telling us that is 120 degrees. So that tells me that the intercepted, that this angle right here, okay, this inscribed angle is going to be half of that, 60 degrees. Okay, and so the angle is 60, the arc's 120. So you can think of it two ways. It's half of the arc, or the arc is twice as big as the angle. So go down here and look at this example. It tells us the measure of arc AB is 50 degrees. So I'm going to go ahead and label that here. It tells us arc BC is 180 degrees. So what does that make BC? What do we call BC then if this angle is 100? This arc's 180 degrees. Call that diameter. That's our diameter to split our circle in half. This would be a semicircle. So what they're doing here is they're asking us to find angle ABC. So this angle right here. Okay, so the first thing we're going to need to do is we need to find out what this intercepted arc is right here. From here to here. Well, remember, two ways you can think about this. The entire circle is 360, or we know BC is a diameter, so we know this half over here has to be 180. So we could take 180 minus the 50 that we already have. That tells me that this arc right here is 130 degrees. And then we know that the angle, this inscribed angle here, is half of that arc. So I know that that angle has to be 65 degrees. Okay, so this angle is half of this arc. All right, I want you guys to go ahead and try this example here. Find A and B, measure of angle T, and the measure of arc QR. So go ahead and pause your video, work out this problem. Once you're done with the problem, go ahead and unpause your video and it'll give you the answer. All right, here's the two examples answers you should have got. Angle T is half of the arc, so half of 48 is 24. For the measure of arc QR, we had to find arc QT first, which is twice as big as this angle, so that's how I got 100. And then we know TR here is the diameter, so we can take 180 minus 100, and that's going to give me 80 degrees here for my arc. All right, go ahead and go do practice number 7.